Alright, siseselana ku trial examination question paper, but this time is khuluma ngalo question 3, VPM, the vertical projectile motion. Check out the description box for more content, more questions engwa recordile for the question paper. Now, lana basiphe a statement, but a ball is thrown vertically upwards from the top of a building with an initial velocity of 12 meters per second. The ball leaves the thrower's hand at a point that is 50 meters above the ground. The ball just misses the edge of the roof on its way down and bounces off the ground. Maybe a petty tennis ball or a petty basketball, who knows. But le ball analfika phansi liwenzani liyo bounce. Ignore air resistance. 3.1. Okay, this question I call that difficult, but there's a lot to take away from this. Now lana gibati determine the time taken for the ball to reach the maximum height when it is thrown. So the maximum height lana, we can see that if final velocity about equal to 0 right, at the maximum height. So the initial velocity la is equal to 12, basiphe yona nangu 12, but actually ball na uliphosela phezulu nalifika lapha ku maximum height liyo stop temporarily naqeda liyabuya liyenzani liya drop again. So that's why city velocity at the maximum height is equal to 0, right? So sifuna the time it takes for the ball to reach the maximum height. So delta t is unknown, right? So sebenzisa which formula, check formula sheet yakho, you realize ukuthi f final, v final is equal to v initial plus acceleration delta t, right? I do have acceleration, which is the gravitational acceleration. Delta t initial final I do have, right? So I'm choosing up as positive. You need to choose the direction like vertical projectile motion whenever we enter a calculation. Whether you choose the up as negative or positive, it's fine. Make sure you stick to that direction of my calculation. Initial velocity 12, so it's positive 12 now, so it's up. Then which you negative 9.8. Gravitational acceleration is always acting downwards. Delta t unknown, right? Basing transpose 12, your figure minus 12 is equal to minus 9.8 delta t divided by negative 9.8 divided by negative 9.8. Cancel. Delta t is equal to negative 12 divided by negative 9.8. Answer here to bani 1,2, as we started to 3 decimal places, 1,224 seconds. Now answer here to again. Then lagu 3.1.2, but the maximum height reached by the ball above the ground when it is thrown. The maximum height reached by the ball above the ground. Alright, hey, silungu lesilungu singandlula phela naso, singavele sidlule sibaleke nje khona la. The maximum height reached by the ball above the ground. So the question lana iti, thola the maximum height reached by the ball measured from the ground up, right? Calculator them. Okay, some questions are not for the maximum height from the instance it is thrown up, but for the height le kuphela. But now above the ground, it means that komele measure from the ground all the way up. So but into yokuqala komele si calculate delta y, this piece of information. Yokomele si calculated this one and okay, this one from la to la, right? so ngathola le piece lenyo add nalo 50 so that izonginikeza le distance le, the maximum height from the ground, ne? So make sure ukuthi uyayifunda i-question, uyifundisise uyi-understand, right? Hayi ukuthi siyanishaya isilungu, just ukuthi anifunda ama-questions, right? Aniwafundi niwafundisise ukuthi niwa-understand. Alright ke, now la ku 3.1.2 okay, how do we approach this one? Alright, asebenzise le information yethu leya. V final kusese 0, V initial I'm still choosing up as positive na la kule question 3.1.2. Initial kusese 12, G minus 9.8 bese ngifuna delta y this time. What else do I have? I'm avoiding using isikhathi la. You know why? Ngoba isikhathi sami singaba wrong. Yes? But anyway, ungasebenzisa nasisikhathi na ufuna. Noma singaba wrong, i-calculation yakho la ku 3.1.2 izoba correct ngoba basebenzisa ilogaji i-positive marking, isn't it? Why the answer ki wrong la phezulu bese wayisebenzisa substitute in the next question uzothola correct, ne? Alright, now delta y, but mina isikhathi angeke ngisebenzise, ngizosebenzisa another formula. This one, uv f squared equal to v initial squared plus 2g delta y equal to the v initial ubani 12, 2 g ubani minus 9.8, delta y ubani unknown, v final 0 squared, 0 lana kuyoba 144 minus 9.8 times 2 minus 19.6 delta y, right? Transpose kuba 144 equal to minus 19.6 delta y. Then you divide up both sides by negative 19.6 both sides. Negative 144 divided by negative 19.6. Answer should be 7.35. 7.35 meters. Now you answer it together. But this is the delta y. So the maximum height from ground is over equal to 50 plus 7.35 is equal to 57.35 meters. Now you answer it together. Now let's move on to 3.1.3. 3.1.3. But is calculated the velocity of the ball at t equal to 4 seconds. Is this a trick question? For how many marks? 3 marks? No. Okay, let's choose up as positive. So Lanabasi put delta t as 4 seconds. What else do we have? It's the initial velocity, 12 meters per second. What else do I have? Oh yeah, g. I have g, which is equal to negative 9.8 squared. Then ngifuna in final velocity, right? Yeah, final velocity. Ngifuna the velocity of the ball at, all right, ngifuna final velocity. Therefore, let's use this one. Final v initial plus g delta t. I just plug in my values formula. Lana yoba 12 plus g negative 19.8 delta t 4 seconds. So I just substitute and then I calculate again. Answer yami about 12 plus negative 9.8 times 4. answer negative 27,2 meters per second. Therefore answer yami v final yoba equal to 27,2 meters per second. Downward, you need to provide a direction. The negative is ukuthi we are going down again manje ngoba up was taken as positive, i-answer iphume as negative, it means siyakuphi siyashona phansi ke manje. So this is the direction of the velocity, since velocity vector. 3.1.4, the position of the ball above the ground at t 4 seconds. Alright again, so le ball since at t 4 seconds le ball seliya phansi ke manje ngenzeka ukuthi le ball sella. So the question ifuna ukwazi ukuthi le ball li how far above the ground, right? Sifuna ukuthola le distance from la le ball likhona to the ground, yabona, to the ground. Le ball ngenzeka libe la or ngenzeka ukuthi le ball la. So sifuna the distance from la le ball likhona to the ground. Ngenzeka ukuthi le ball lila, we don't know, lingaba anywhere, sifuna the distance from la to la. So now lena singayi approach njani mara. Okay, so how kuzofuneka ukuthi sicalculate delta y. The delta y traveled from the maximum height all the way up to this point, right? All the way up to this point, all the way up to this point, all the way up to this point, delta y, or from la to la, from la to la, from la to la, right? And so draw at different points la. So kahle sifuna the distance from the maximum height to la le ball selikhona manje, ne? So ngifuna delta y from the maximum height to the point where le ball selikhona. So let's take this point. Asithi we are assuming ukuthi le ball selifike la ke manje, ne? This is the distance the question is ifuna, right? But the first thing as we calculate, it's this delta y from the maximum height to the position where the ball is, right? So sizofuna delta y, meaning that ngizosebenzisa le formula lega, delta y v initial delta t plus 1 over 2g delta t squared. Delta t squared. I'm choosing up as positive again. I'm choosing up as positive, equal to what is initial begu 12. Initial begu 12. Yeah, the initial velocity begu 12. So sizothi manje 12 4 seconds, 4 seconds, t 4 seconds plus 1 over 2. What is g ke manje? What is g? It's negative 9,8. Delta t 1 4. Then we calculate city 12 times 4 plus 0,5, which is a half, times negative 9,8 times 4 squared. I should get negative 30. Negative 30,4 meters, right? But the negative is still good, it's 30,4 meters down. The negative is the direction. Remember, with delta y it's a displacement. So displacement is a vector quantity, right? So it means from la all the way up to la, it's what? It's 30. Ne? It's 30. It's 30. It's 30 now. Sesifuna ini the position of the ball above the ground. Okay guys, beganda. Let me explain something before ngiqhubeka la. Yabona le formula le. This formula le. Yenza so. Uma we implement yenza so. Also, since I chose up as positive, this distance is equal to this distance. Yes, this distance is equal to this distance, or this displacement is equal to this displacement. So if it's positive 20 la, lana kuyoba negative 20. What is positive 20 plus negative 20? Basically ziyacancelana kahle kahle. So this formula le, it cancels out lo 20 nalo negative 20. Therefore it only considers the height from the moment the ball is thrown, right? So you measure from here all the way up to the point le. So it means that lo 30 lo uyo subtracta la kubani ku 50, right? Asho ngifuna le height le from the moment le ball analifika la all the way up to the ground. Sifuna le distance yala. So therefore lana sizothi ke manje, and it's negative la ngoba le ball seliya kuphi, seliya phansi, and displacement vector ke na. So le height cancel le height le, right? Kwasala this piece le piece le so is subtracta kuphi ku 50. Basically that's what the formula does. So lana sizoba nobani 3.1.4. so answer yethu nayi answer yethu sithi position above ground about 50 minus 30,4 equal to, so 50 minus 30,4 is equal to 19,6 meters above the ground. So now answer it to guys. All right, question 3 akaphelelanga la. No. Now bonus question ke. Here's a bonus question. 3.2 wherever this draw a velocity time graph. This is the last question for question 3 wait, ne? I apologize for not showing the question lena lapha ekuqaleni. But now. On hitting the ground, the ball bounces vertically upwards with an initial velocity of 12 meters. So now again, this was the building. 9 daughter imile lapha, phose le bola laya phezulu, labuya. So nalifika la phansi, it bounces off ngelo kanje nge initial velocity of 25 meters per second. Draw a velocity time sketch graph for the motion of the ball from the time it was thrown vertically upwards to the time it reaches its maximum height after the first bounce. So sifuna draw a velocity time graph from the moment le bola baliphonsela phezulu until ilifike la ku ground, bese lishayisa ilo kanje I ground, then until ilifika to the maximum height after the first bounce. Use the ground as a reference point. Indicate the following in your graph: the initial velocity of the ball when it was thrown, senze so. Alright, senze so. Alright, let me get a black pen. Alright, take a match. Now lana sine velocity in meters per second, and as all along I chose up as positive. Now lana kule sketch you need to choose a direction. I'm still sticking to it up as positive, choosing upward as positive. Now asize lana ke, initially we had a velocity of 12 la, right? Izoba ngapha on the positive side ngoba the initial velocity it's going up angisho. So sino 12 la, right? Sino 12, then le bola laya phezulu, then le bhola la phezulu, what happened to velocity yakhona? The velocity decreased ngoba nalifika lapha phezulu ibhola, we have a velocity of 0. Na velocity yethu of 0, athi ngithole a proper line la. Na velocity yethu bani u0 ke la manje. Velocity yethu 0. Then but isikhombe in the time taken to reach the maximum height when it was thrown vertically upwards. The time taken to reach this maximum height la, to reach this maximum height was 1,23. See, calculated this one on the first question, right? Siyabuya ke manje, but the initial velocity of the ball after the first bounce. Remember, ungakhohlwa phela, ungakhohlwa. Le ball analisuka la ku maximum height, then it starts picking up in speed again, but in the opposite direction, meaning that the line will extend. Will extend. Nalifika la, le ball liya stop, lishayisa ground ke manje. Boo. Shayisa ground. Naliqeda ukushayisa ground, what happens? Siba ne gap la. Why do we have a gap? Ngoba le ball ali in contact with the ground, kuba nani ne zero velocity, but temporarily so, right? Leyo contact with the ground izoba so temporary ngale ndlela lekuthi angeke ulibone li stop le ball, meaning I velocity yala yoba u0 nakhona, yabona? That's why kuba ne disconnect la. Therefore le bhola lenzani libuye lisuke ngani nge initial velocity of 12, and then naliqeda ukuthi 0 la asho be yehla nge velocity ka negative. Now yaba u0, say change direction yoba ubani positive again, going up, yosuka ngobani ngo 25. Then nayifika nayifike la ku 25, nayibamba initial velocity of 25, what's going to happen to iloka speed or velocity la le bhola? Yoya phezulu, and naya phezulu, so the velocity will also decrease. So therefore besibamba ubani u0 ngoba nayifika la le bhola lizobamba ini a velocity of 0, just like when it was thrown la. Nayifika le phezulu yobamba u0 besibuyela phansi futhi. So that's why velocity decrease again la. So on the y-axis we have time. You need to label the x-axis yakho and the y-axis yakho. So this is the sketch, the velocity versus time graph. I hope you enjoyed this video. Check out the comment section for more content and recorded for this question paper. It's not November, it's September 2022, but by Bale a KZN this one. So for now guys, thanks for watching. Asponani on the flip side. Peace.